All right, so we are gonna wrap up this 1.6 notes and then do some more practice. Okay. Everybody's with me? All right, so first thing I want to do is I like doing my T-chart method, so I'm going to keep doing that. If you want me to show another method, I'm happy to do that as well. I think I walked through it a little bit last class, but I'm going to start by making a T-table of all the points on this graph, and then I'm going to put it for all of my other problems, okay? So I've got 1, 2, 3, 4, 6, 7 important points that we're going to list here. -3, 0, -2, 1. 1, 0, 0, -2, 1, 0, 2, 1, 3, 1. So those are all points that I'm going to use for the rest of these problems. These are my original points. We want to transform these points.
But why?
It's just a new picture.
Oh.
Are you with me on this new picture? Because we did this picture over here. And so now it's a new set of problems, so I just have a new picture.
Oh.
You're the wrong one? Okay. Now I'm going to use this on all of these problems though, so I am going to do some notability magic and copy paste. If you only want to make like one T-table and then just use it each time, I'm totally okay with that. This is all your kind of personal preference. Whatever it takes for you to get this correct is what I want from you guys. I'm also setting up my graphs. So once you have your points, I'm going to go zoom in on that first one, and you can still see my T-table if you need to be copying and pasting it over. But I've got two things that are happening to this graph, okay? First thing, let's deal with that +2. It's on the outside, so is it affecting my X or my Y?
Your way.
Y. Outside Y. And I'm going to do, what does that do to my graph? Moves it up, down, left, right. Up 2. Good, so I can think about it that as doing +2 to all my Y's. So if you like this method like I like it, I'm going to go through and I'm going to add 2 to all of my Y's. Now, anything inside the parentheses that's close to the X affects my X. So that -1 is going to do a flip, but it's not going to flip like this way, like we're used to it flipping, like across the X axis. It's actually going to flip across the Y axis. It's going to flip like that. Okay. Normally I do the opposite operation here, but if I multiply or divide by -1, it's the same thing. So this is going to flip across the Y axis. Flip over Y axis. And so I'm going to take all my X's and multiply by -1. So that just means they all switch. And then now I have all these new points. Yeah, yes.
When you're doing the T-chart, do you really need to remember like that whole like, oh, if it's negative, then I'm switching over this?
Not necessarily.
Diagonal. Oh,
You're asking just because I'm doing my T-chart and I'm doing that times -1, do I need to write those or do I need to know those words? Not necessarily. I think it is helpful to have an understanding of that so that if you start doing something and you're like, oh, that didn't flip it and it should flip it, then that's a good way to double check. So now I'm going to go graph all of these points. These are my new points on my new graph. Here, 3, 2, 0, 2, 2. And so if I look at my original graph compared to this one, I can see, I'll just zoom out a little bit, I can see that it got flipped over that Y axis. And I can see that it moved up a couple of units. Is everybody okay with that so far? I like to do a little visual check. Does it make sense, the transformations I did compared to the original? See where you're at. All right, can we go to the next one? Am I moving too fast or okay today?
You're good.
Okay, good. Just tell me if I'm going too fast. This 1/2, does it affect my X or my Y? X, very good. I'm doing the opposite operation of what I think. So right now it says times 1/2. What am I actually timesing by?
Oh,
2. Yeah, guess.
Oh, wait, can I see again the top one, the first one we did? Okay.
Like enough. So I'm going to multiply all these by 2. Technically, this 1/2 is going to stretch my graph horizontally. Again, it's opposite of what you think. You think a fraction makes it shrink. Inside the parentheses stretches it. And it's stretching it like kind of this horizontal compression, like an accordion. If I'm playing an accordion, it stretches and shrinks like this. Stretch horizontally. And we're going to see it when we multiply all these by 2. -6, -4, -2, 0. +2, +4, -6. Okay. So I'm going to go ahead and graph that. I'm going to go as far as 6 on both sides. 1, 2, 3, 4, 5, 6. If we compare that to what we had before, it does kind of look stretched out. Yeah, Nikki,
so you remember there, would you?
we'd make it a fraction, we'd divide. So if inside here said 2x, then what we would do is we would do x divided by 2.
Maybe five.
You do the when you're inside the parentheses, you do opposite of what's being done.
Oh.
So right now it's being times by 1/2, so we're gonna multiply by 2 to opposite.
Like,
Everybody good? I know it's kind of weird, I know it's kind of funny. Let me know if I can answer anything. Okay, should we look at number C, an absolute value one? Do you remember what we talked about the absolute value yesterday when it's outside of the f of x? First off, when it's outside, it affects the what? X's or Y's? Y's is on the outside. So I'm just going to take this and I'm going to do the absolute value of all my Y's. What does that 1 do to my graph?
Add 1 to Y's.
Add 1 to my Y's. Which one am I going to do first? Absolute value or add 1? Absolute value. Good. Do any like multiplying thing first. Last thing we do is add and subtract. Okay. And so the only absolute value one that really is affected is this one right here. This -2 just becomes a +2. And then now I'll go through and add 1 to all of my Y's. Like, do I still have everybody? Have I lost anybody yet? Doing okay? Okay. I know this can be a really tough thing, a slippery slope. So if you're falling off the boat, please let me know. Now I'm gonna go graph them. So I've got -3, 1, -2, 2. If you notice, I'm just going to go to the original really quick. You can kind of see them both at the same time. The absolute value only took this part and flipped it up. So it was up here instead. And then I took the whole graph and I just shifted it up 1 unit. Absolute value on the outside of the f of x only affects your y's. It makes them all do absolute value. Makes them all positive. Now, on the contrary, we've got absolute value inside of the x, and that's what that last problem is, isn't it? Let's go do that one. We have absolute value inside with my x, and I have a negative in front of the f of x. Let's deal with the x's first. Yeah, Kate.
Wait, so it's the absolute value, lines, I guess inside of them, if there's a line, it's outside of them.
If f is inside of the absolute values, then that's being done to the y. Because remember earlier this week, we talked about how y was just f of x. So you can just think of replacing that. This time, since the absolute value is inside of your f, the f letters outside the absolute values, we're only having the x is getting absolute valued. Yes.
When you have an absolute value, like whether it's in the X or Y, you gotta like whatever's like if it's X, right? Like here, and you have to like grab whatever's in the negative and flip it.
You're gonna graph whatever's in the positive and flip it. Remember yesterday I drew like a you're talking about the y's. The y's, you graph whatever was negative y, and then we flip it up, right?
Yeah.
When it's x, it's a little different. Remember I drew that
Great.
I drew that like function picture yesterday. When I do the absolute value, it's being done before I even put it into my equation. So I'm going to take all my positive values. That's always going to work. And then my negative values are essentially going to get coded to their positive values. So if I plug in -3, it's going to act like it got plugged into +3. Because I'm doing the absolute value of that -3 before I take the function of it. When I have absolute value of just the x, it's only my positive x's. And I graph that on both the positive x side and the negative x side. I'm graphing only my positive x's, and then that's the same number for -1, -2, -3. So let's graph it, okay? I've got, shoot. 0, -2, 1, 0, 2, 1, 3, 1. And this isn't the final graph, so don't actually finish graphing this. Just kind of listen to me for a second. And then I'm going to reflect it over to the negative side, because if I plug in +1 or -1, it's the same thing as plugging in +1, and I still get 0. If I plug in -2, it's the same thing as plugging in +2 and getting 1. If I plug in -3, it's the same thing as getting +3, and I get a +1. So it's going to be a mirror image. Now, this is not the final answer though, because what have I not done yet? That's part of my equation.
Oh.
Made it negative. And what does that negative do to my graph? So it flips it over the x-axis. So that means I'm going to take all of this and I'm going to flip it this way. Okay, so that means I'm probably just going to erase all of this. When I go do my little t-table, which I have been like talking, I've been talking very positively about this t-chart. Let's think about what that's going to look like. I keep erasing too much. Okay, when I go do my t-chart for this, I've got only my positive x's, so I only care about these. And now I'm going to do the -y of those. So I'm going to take all my y's and multiply by -1. So instead of -2, I get +2. I keep my 0 and I get -1 and -1. I feel like I was explaining something else and I didn't do it. Are we okay so far? Did I lose anything? Did I lose anybody? So now I'm going to go graph those pieces. So instead of being at 0, -2, I'm going to take that guy up and put him at 0, +2. 1's going to still stay at 0, but 2 is going to be at -1 instead of +1, and so is 3. And then I'm going to reflect those points across my axis.
If your negative x is the same.
Negative x's have the same y. So I can think of this as positive and -1, and positive and -2, and positive and -3.
So you don't draw any of the points that are negative. You don't draw them.
Nope, don't do those.
feel like I can get this now, but I think I would not get it on a test.
Okay, so what we're about to do is I'm gonna give you another problem and we're gonna do a bunch more of this. Cause I think that we're getting better at it, but I don't think we're good enough to keep going. So I have this paper right here. And what I want you to actually do to start is there's 9 problems that are just like describe the transformation. Up 7, down 2, right 3, multiply your y's by 2. So I want you to do those 9 first. Then we'll go over those and then we'll do maybe 1 or 2 together. And then I'll kind of just like let you guys go, bring you back in, let you go, kind of all that for the rest of class. Does that sound good? If we feel good enough on this, I'll stop you and we'll work on our homework. But this is just not for a grade, only to practice. Can we feel better about this transformation stuff? And it's a little bit easier because I have actual graphs for you now. I think it's harder when there are no graphs. I think that's if not limited.
I found it was a lot.
So take one, pass it back.
Wait, what do you mean describe the following?
What I just said out loud. Up 2, down 7,
Oh.
right 4. Multiply the y's by 2, stretch of 2, flip, blah, blah, blah. So take a minute, do it by yourself or with a neighbor, these 9 at the top. We'll come back in 3 to 5 minutes. All of them are cubes, so you don't have to worry about the cubic function. They're all gonna be x to the 3rd. But what is that cubic function doing? Is it stretching? Is it shrinking? Is it flipping? Is it up and downing? What are we doing here?
Essentially.
What does the 2 do out front? What, x or y? But like, I write strip it, the y's. Or you could even take time to do all the y's. Technically, it just gets. There. We're gonna grab this. I do it 10 by 2 and then do the. You need to do that. Okay.
I saw on TikTok. But she was all seven. I think that's what I did out when it's like in China.
So there's no significant normal. I know there's stretching. I don't want them stretching. Ratcheting and printing. We're gonna take all of our wires. All of our wires.
Okay. So when I put it, yeah, it's like.
You could write y or you would write vertical stretch.
Okay, it always works the stretch.
Always works. Okay. If it's inside of the accent or not.
Thank you. So,
Negative, yes, when you multiply. This one? Like, Over here, if it was below the x-axis, we have to look at x-axis, this guy could have been like that. No. Could have been. Why would you do that? Although we should have.
Hey, why? It's negative a flip.
Negative's a flip.
So would that be all, or is there gonna be so much?
It's a Your hands are to the right, and you're going to say the wrong thing. This is vertical. Cause even though my hands are like horizontal, I'm flipping it and the Y is switching.
So it's a vertical, which means it's doing this.
The number up front, that two actually is a stretch by two, not up by two. It's only being up or down if it's added or subtracted, not multiplied, right? So that one's right by two, that's good, left four, this one should be down at 7. How do I know if it's on? When it's inside the parentheses, that's when it's opposite, and that's when it's doing horizontal things or affecting X. That's inside both the X. If it's outside or there's no parentheses, that's affecting. Down. Yeah.
So if it's a whole number, this stretch, this visually, then if I had it like this and that would be.
They stretch pretty opposite. We'll take like another minute, we can talk about these.
What's the square root stretch?
What's the square?
Square root. The cube.
The cube doesn't the shape of the graph, it just makes the cubic.
So I don't put anything.
You don't do anything for the cubic.
So this is,
They're all cubic graphs, and we're just stretching cubic graphs.
going down, right. Flip, flip, and left. Up, stretch, right one, up 7. Stretch, left 3, up 2. Thanks. And now we're graphing.
And then we'll graph in a second. No, we're not graphing those, we're graphing other things.
Okay.
All right, guys, trying to find a stopping point. Let's do some more of this. Let's go over these 9.
We're just squaring inside of the.
The cube is the parent function.
You said what?
I might like the third outside.
Yeah, but what if you were, if you had the square inside?
We're not doing that.
Is that like,
I don't think,
wouldn't that be like, or?
I think you're trying to do something that we're either not gonna do or we would never do.
Okay.
Okay, so all of these are cubes. So we don't have to mention that they all come from the same parent graph. Bring it to me,
Someone say it.
What does a 2 do in number 1?
Stretch.
Stretch. This is a vertical stretch.
Say stretch too then?
Stretch by 2, You could also write like 2 times y, because that's what's happening. The y's are all being multiplied by 2. What does the negative on number 2 do? Yeah, Carson.
How do you know if it's a vertical or horizontal?
Excellent question. How do I know if it's vertical or horizontal? Horizontal things happen inside parentheses. Vertical things happen outside the parentheses. Because vertical things affect the y. So if you're doing anything to the y, it's a vertical change. Up and down is a vertical change, right? Multiplying all my y's by 2 stretches them by 2. If it's inside the parentheses, it affects the x's, and that means it affects it horizontally. Left and right is horizontal, and when I don't have any multiplying on the inside over here, but like here, this number, this right here, that affects my x. That affects my x's because it's on the inside. Yeah.
If it's on the inside, like that one, would it shrink?
This?
Yeah.
That's going to flip it across the y-axis
When would it shrink?
when it is a whole number, 2x.
Okay.
Because you're doing opposite operations, so I'd have to divide. All right, what about number 2? What does that negative do to my graph?
Flips.
Flips it, and it flips it across the y-axis.
But if it was in parentheses, it would be axis.
No, I did that wrong. I did that wrong because I was thinking of the last one. You're right.
Oh, now you're messing.
I messed.
I just got it and now.
You were right. Flips like this. Flips across the x-axis. The one we just did was on the inside. That's why I was flipping. I gotta. I have to be so careful with what I say because like you guys are all like right on like the fence of like understanding and not understanding. And every so often, if I mess it up, I tip you over to the not understanding, and I'm like, no, we were so close. I messed it up.
Wait, so for this one's the x-axis?
This one's the x-axis because it's flipping like this. All the y's are flipping. -1 times my y. Did I tip Kate to the wrong side?
Right? And the only thing I don't get.
But if you, the negative word parentheses, you need to be flipping on the y-axis.
Okay, you're on the right side. Stay tipped over there. Okay, what is that 7? Oh, Joey.
Said if it's a whole number inside the parentheses, it's always shrinking. Okay.
If it's a whole number outside, it's gonna stretch it vertically.
Oh.
And if it's on the inside, it's horizontal.
Yes.
Okay.
All right, what does that -7 do to my graph?
Down 7.
Down 7. Okay, we got that. That's like y minus 7. All right, what about number 4? What does the 2 do to my graph?
Oh, right.
Good, right 2.
So the cube outside, just like it.
That's just like the BFF graph we're doing. So I could do all of this with like a reciprocal, with a square root, with a squaring, with a cubic. I just chose cubic. What about number 5? Let's do the 4 first. What does that 4 do?
To the left 4 times.
To the left 4 times.
Wait, what was? The x was.
Oh, sorry. That should be 2, not.
Oh.
Or we're going right 2. So we're going left 4, so that's taking all of our x's and minusing 4. What does the negative do out front? Flips it. Oh no, I said Nikki the wrong way too. Flips. And it's like -1 times all your y's. What about on the next one, that 1/3, what does that do? Shrinks it. It shrinks it vertically. It's like doing 1/3 times all my y's. And then what does that 1 do? Up 1. That's like y plus 1. When I do my 1/3 x to the third plus 1, am I doing the 1/3 to all my y's first, or am I doing the 1 to all my y's first? 1/3. We're going to multiply first. All right, can we look at the last 3? Okay. Number 7, there's a lot going on here. The 1, what does that affect? My x or my y?
X.
X. What does it do?
Right one.
Right 1. So it's like going x plus 1. What about the 4? What does the 4 do? Stretch, it's going to be 4 times all my y's. It's a vertical stretch, 4 times all my y's.
If it was a -4, would that change anything?
It would be, we're stretching and we're flipping.
Okay. But if it was inside the parentheses, it would just be like.
If the negative,
No, if the 4 was.
the 4 was inside the parentheses, it would affect my x's,
You're not the y.
not my y's. What about 7? What does that do to my graph?
Up 7.
Up 7, very good. What about number 8? What does the 3 do to my graph? Vertical stretch. It's y times 3. What does that -4 do?
Down 4.
Down 4. And then what about 9? What is the, we'll do the 2 first. What does that 2 do? up 2. Y plus 2. What does a 3 do?
Left 3.
Left 3.
We don't have.
This was just me defining these transformations. Is everybody good, Joey?
Is there such a thing as a horizontal stretch?
Yes.
How does one achieve that?
What we just did on our, what we were just doing on our notes, remember when we had that 1/2? That was a horizontal
Oh, and it's
stretch,
inside.
because it's inside, and we do the opposite of what they tell us,
But if that was like 2, it would be shrink.
it'd be shrink.
Because it's opposite.
Maddie,
So, for like order of operation, like on 7, I would do doing 2 things to Y.
do the multiplying thing first, do the adding thing or subtracting thing last. Maggie,
So are these open tests?
yeah,
How many? Like,
anywhere
on
from
the
like
line-
1 to 6.
Can we do 1? I got this.
On your quiz on Friday, it's gonna be 3 of them.
That's a group. That's we can like have each other.
Yeah, so use each other and let's do some more practice, so then by the time we do our test, you'll be ready to go. Yeah,
What
Nick,
if,
Number 6. You did multiply that one by 3 because it's.
you're gonna multiply by 1/3. This is outside. If it was inside, you'd multiply by 3. Yes.
Can you use your notes on that quiz?
I'm not here. It's open calculator, it's open notes, it's open friends. I don't think Google will help you. Feel free to Google anything.
And 1.5, no, is it 1.4 or something?
No, you already tested on 1.4.
Oh, 1.5 to like 1.7.
The 1.7 won't be on there. It's only 1.516. Okay, can we keep going?
Yeah.
Okay, I'm gonna do as many of these as I can out loud. If you feel good and you wanna just quietly try them on your own, go for them. If you're like still struggling through, I would maybe listen to me. I think we'll definitely do this one right here, and then maybe we'll try and do all of this front side, and then the back side will probably like jump around to the ones that I think are important to get as many done in the next 14 minutes as we can. Okay. I always like to start with my T-table, so I'm gonna make my T-table over here off to the side. You can always just keep referencing back to the same one, or you can redraw it, that's fine. I think it's -8, 0. I did this earlier, let's see how many I can, -4, 4, 0, 0, 2, -2, 4, 0, 7, 3, and 10, 0. I kind of remember some of those points from earlier, but those are my original points, and I'm going to use them as we go. Copy and paste this all around the room. I want to do this bottom left one first, because I think it's the harder of the 3 on the front page. Okay. Help me out. What does that negative do out front? Flips it how? Am I multiplying my x's or my y's by negatives? Y's. Y's by negative. So I'm going to do -1 times all my y's. What does this 1 do to my graph? Moves it up 1. So I'm going to do y plus 1. Do I have anything affecting my x's? Do my x's change here? Nope. Do I multiply by -1 and then add 1, or do I add 1 and then multiply by negative? Multiply first. So we're going to take all of our y values, multiply them by -1, add 1. And I'm going to go just all in order. I'm going to just multiply them all by -1. And then now I'm going to go through and I'm going to add 1 to all of them. Once you've changed all your y's, multiplying all of them by -1 and then adding 1 to all of them, now I'm going to graph them on my graph. I'm just going to go 1 point at a time. So I'll go -8, 1. Go -4, -3. 0, 1. 2, 3. 4, 1. 7, -2. And 0. Oh, not 10, 0, 10, 1. So we flipped and we moved it up 1. And if you go and look at that original graph, I can see how I flipped it and then I moved it up 1. That's a check that I want us all to kind of think about. Okay. Let's do one more on the front. Does the top right one or bottom right one look harder? Top, bottom. I mean, the top, all we're doing is what? Multiply all my y's by 2. Probably skate through both of them. Nothing is being done to my x's, so I just multiply all those y's by 2 and then I graph them. And that looks like my original graph just kind of stretched out. Am I moving too fast or are we okay? Yeah, Avery.
So if you had a -2
Mhm.
next to the, like, what would that do?
Right, like this, -2 in front of my f.
Yeah.
That would make it flip and multiply by 2. So I wouldn't just do y times 2, I'd do y times -2. So then it would be -8, +4, -6.
And if it was -2 in the x, like -2x?
If it was f of -2x,
Uh-huh.
that means I'm shrinking and flipping horizontally. So I'm going to take all my x's and we're going to divide them by -2. You do opposite sign from the inside the parentheses, you do the normal sign outside the parentheses. All right, should we do that last one, that bottom right one real quick? We can do that. Yeah, Maddie?
What did you say? Opposite sign, outside.
Inside the parentheses, do opposite of what they show you. So if it's a plus, you minus. If it's minus, you plus. If it's a multiply, you divide. When it's outside of the parentheses, you just do exactly as they tell you. If they say multiply, you multiply. If they say add, you add. You guys want to do this bottom right one too?
Yeah.
Okay. What does that 2 do to my graph? Right, 2. So you can think about adding 2 to all of your x's. What does the 3 do to my graph? Down 3. Does it matter if I do my x plus 2 first or my y minus 3s first? No, they don't affect each other. So just as long as you get both of them done, it doesn't matter. So you can move all your points right too by adding 2 to them. And then we can take all of our y's and minus 3. And then we'll just take those new points and graph those. Everybody doing okay? I have you all? Are you guys hanging with me so far? Should we go do some on the backside? Okay, I'll leave this up for a minute. You go look at the backside and decide, I've got about 6 more minutes with you. I'll do as many as I can. What looks like it's going to be an issue for you to do alone? That's kind of the question I'm thinking. What seems like it would be hard to do on the backside by myself?
One in the middle, right?
The
Negative.
middle right here. We can do that one.
You did applying the y value by -2 and then moving to the right.
And then what?
And then moving to the right, 3.
Yeah,
right?
that's it. Sounds like you got it. I'll still do it though.
I mean, I thought it was.
Nope. Multiply by -2 on my y's. And then I'm gonna do my 3, we're gonna go right 3.
So only vertical stretches.
I didn't say that.
They're like,
This,
oh, wait, man.
that's outside the parentheses, it's vertical
Yeah,
stretch.
yeah, yeah.
Okay, yeah, Maddie?
So, on the three absolute value one on the back.
Yeah.
What's the difference?
It's a great question. Who's got me? Who knows what one of those is? Guess what's one of them?
One of them is like the absolute value of the life.
Which one is it?
The top, right?
Top right one is the absolute value of what? Of the y's. So since the absolute value is on the outside, we're just taking all of our y's and we're switching them to be positive. And there's no other transformation on this one, so that's all I've got. The only thing that changes from my original t-table, my original chart, is it's just instead of 2 -2, it's just 2 +2. So that's just the absolute value of the y's. Everything else is the same. Who can help me with the absolute value of my x's? Kate? Never mind. Yes,
Oh,
is that hand or no?
yeah, it is.
Okay, perfect.
But I mean, you just get rid of all the negative x values and then just reflect all the positive.
So we graph all the positive x's. Only graph the positive x's. And then we reflect it to the other side.
Is there I mean, what's the opposite of the absolute? Like, since it's inside, aren't you doing like the opposite of an absolute value? You said everything in the parentheses is opposite, right?
I did.
Like,
We're not technically doing opposite though. And I don't know if there's like an opposite of absolute value. So I don't want to keep pushing that, but I like that you think everything inside the graph is. Yes, Maddie.
Nothing changes, you just grab those.
You just only, yeah, so I didn't change anything. All I did was I took my positive x's and I graphed on this side and then I reflected it over there.
And then, if like, we would have one like that, and then maybe like a +2 or something, then when we just like only change the one specific one.
Yeah. Okay. Are we feeling a little bit better about this?
Yeah.
I'll finish this and post an answer key online. You've got 1-6 homework due next class, which isn't until Thursday, and you're gonna do a video lesson of 1-7 on Thursday. Is 1-7 on your quiz? No. Is it on the test next week? Yes. And then that homework will be due by the time I get back. I also have reviews for you guys. If the sub doesn't give it to you, make sure you get a review. And then you also have more piecewise practice, inverse practice, composition practice, because I thought we could use more of that. You'll get that after the quiz on Friday. What was that? Ooh, okay. What do we do here?